So here we're going to look at question 5 from section 2 of the ENGAA specimen paper. In this question, we're told we have a projectile which is fired at a horizontal velocity v, a height of 4 meters above this point Q. When it lands, it's travelled a distance of 6 root 5 over 5 meters to this point at which it lands, from Q. So with this information, the question asks us to find the initial velocity the projectile is fired at. So if you'd like to have a go at this question yourself, then please pause the video now. Otherwise, we're going to have a go at it. So, to try and have a bit of a think about this question, let's do what we normally do with projectiles, and let's resolve them into two different components. So first of all, how about we think about the horizontal component? So, in this case, there's no acceleration, so we simply know that speed is just distance divided by time. We can substitute in the horizontal distance we travel between Q and the point at which the projectile lands to give us that v is just going to be equal to 6 root 5 over 5t. So this is all we can do in the horizontal direction. So let's move on and look at the vertical direction. So here we have an acceleration. The projectile is going to be accelerating downwards at a rate of g. So we can use the Suvat equation. Since it's a constant acceleration, these are going to work out just fine. So with this, let's try and think about what each of these variables are going to be equal to. So s is going to be our vertical displacement, the displacement downwards, which we know is just going to be 4 meters. Then u, the initial velocity, well, we know that the projectile is fired with velocity v in the horizontal direction, so it has no initial vertical velocity. Then the final speed, which I've labelled here as v0, when it hits the ground in the vertical direction, we don't know. We're not told it, so we'll just leave it as a question mark. And the acceleration we know is just going to be g, taking the downwards direction to be positive, by the way. The time it takes, well, we don't know that either. But the time is actually what we're going to want to find, because if we find the time, then we could substitute this into the equation for v up here, and then we'll get a nice expression giving us our value of v. So let's go ahead and try and find that with these other variables which we know. So can you work out which equation we're going to use here? Well, the right one is going to be this, that s equals ut plus a half at squared. Now, thankfully here, u is just going to be 0, so this first term just gets rid of it, it's going to be just 0. And then we can rearrange the expression just for t to get this, that t is equal to the square root of 2s, all divided by the acceleration a. Substituting in our value of 4 meters and our acceleration of g, which is just 10, then we get this. So t is equal to the square root of 2 times 4, all divided by 10, which just simplifies by cancelling the 2 through with the 10 to make it a 5 on the bottom, and then the root of 4 is just 2. So t is going to be 2 over root 5. So with this value of the time, we can substitute it back into the expression we got from resolving horizontally, in which case we'll get this, where I've just flipped the fraction and multiplied rather than dividing. So here our 2 root 5s are going to multiply together to give us 5, which will cancel out with this 5 on the bottom. So we're simply left with 6 divided by 2, which is just 3 meters per second. So this final answer is going to correspond with answer C given in the question.